say, for this one, I am going to take f of x, which equals x minus 1 over x plus 2, and I can actually split this into two fractions. So I can write it as x over x plus 2 minus 1 over x plus 2. So instead of having two fractions with a common denominator and you add it, I just went the reverse way with that. Then what I'll do is becomes two problems. So I want to write the first fraction as a power series representation, and I'll write the second one as a power series representation. And for this, we're going to use this nice little formula. The book shows this with an x. I'm going to show this with a u. 1 over 1 minus u equals 1 plus u squared plus u cubed plus u to the fourth plus dot dot dot, goes on forever. If I want u to the n, but that's the sum as n goes from 0 to infinity of u to the n, and this converges for the absolute value of u less than 1. So I just need to take each of these fractions and manipulate it so it would match this setup right here. I'm going to go with this first one. So for x over x plus 2, I'm going to first off maybe factor off the x that's in the numerator. See, that's x over 1 times 1 over x plus 2. And so I'll do, but that's the same one I have right here. So maybe I only need to do this one time, the power series. This would be x over 1 times 1 over, I want to get it to match this formula. I'm going to just reverse this, use the commutative property, and write 2 plus x. So I need a 1 in the first spot. I can get that by factoring a 2 out of the denominator. Well, this would be I'm going to make that a 1 because I wasn't quite ready to do that. So 2 factors out, and this becomes 1 plus x over 2. So I'll rewrite this x over 1 times 1 over 2, and then I need the minus sign, so I'm thinking minus negative x over 2. 1 minus negative x over 2. This 1/2 I factored out. Let's go ahead and write this as x over 2. So x over 2 times 1 over 1 minus negative x over 2. So this is what I'm going to write as a power series. And u would be what expression? Negative x over 2. So we're going to end up with this. For x over x plus 2, that would be x over 2. I'm looking at this, and all I really need to do is substitute negative x over 2 in for u. So this would be x over 2 times the sum, as n goes from 0 to infinity, of u to the n, but u is negative x over 2, so that's that to the n. So that's the first part right here. In fact, that's also the answer for the second part, because that second part here, minus 1 over x over 2, is the same thing I just worked with right here. From here, be the same steps. So this problem from the book, which was x minus 1 over x plus 2, there's the function. This would be, I'll write this step again, x over x plus 2 minus 1 over x plus 2. And we found that this first fraction is x over 2 times the sum, as n goes from 0 to infinity, of negative x over 2 to the n. Well, the second fraction is this sum as well, minus the sum, as n goes from 0 to infinity, of negative x over 2 to the n. And I'm gonna put brackets around this, but maybe I don't need to quite do that. You cannot do that subtraction until you would do this multiplication. But if you look at this entire thing, I could say, well, let's go ahead and factor out this summation. I'm looking at this term minus this term. And if I factor that out, I'm going to put it at the back of the problem. I would have x over 2 minus something, think about what that is, times the summation, as n goes from 0 to infinity, of negative x over 2 to the n. What goes right here? A 1. That's a 1. Because I got this term, I factored out my summation. I got minus the same summation. In fact, here's the 1. I can just put it in the front of that. So that's, here, I'm going to leave it like that. The back of the book might have something that looks a little different. Now, where does it converge? This converges when the absolute value of u is less than 1. So my u was negative x over 2. So when the absolute value of negative x over 2 is less than 1, it converges. I can sandwich this between negative 1 and 1. In fact, the absolute value of negative x over 2 is just x over 2. And then multiply everything by 2. So negative 2 is less than x is less than 2. That's the radius. No, that's the interval of convergence. What's the radius? The radius of convergence is 2. Okay.